Welcome back to a second tutorial looking at a different way in which you can use cross macros to make C and C++ code more maintainable. If you're unfamiliar with cross macros, please watch the first tutorial which introduces them and how to use them to create and maintain a C or C++ enum type. The use of cross macros to generate enum types, or functions or variables or whatever, should be familiar. But this tutorial describes a way in which cross macros can be used to generate data. Here we use them to generate a user-to-action permissions bitmap, where a library of actions has been made available for users. Over time, the number of actions available has grown, and so the bitmaps have become laborious to maintain manually. This is an example of how flexible the cross macros technique can be. The problem we want to solve is this. We have a set of users like Groucho Marx or Phil Silvers who may perform actions like joke, dance or deadpan. Each user has permissions to a custom subset of the actions. The binary that implements them contains bitmaps representing these permissions. They are manually maintained, which has become laborious and error-prone. To insert a new action, for example, you need to find the corresponding bit in the bitmap, set it appropriately for the new action and given user, and then shift all the bits above it up by one, and then recalculate these new hex values. In use, the program looks like this. When logged in as one of the users, you run doAction, passing the name of the action you wish to execute as an argument. In the example, the user, Phil Silvers, wants to perform a joke. To enforce the permissions, the source code for doAction contains a bitmap for each user expressed as a hexadecimal value with one bit assigned to each action. If in a given user's bitmap the bit for an action is a 1, then the user has permission to use the action and doAction will perform that action. Otherwise, the user doesn't have permission and doAction will exit with a suitable error message. An example of a lengthy permissions bitmap is shown. More usually, we see cross macros being used to generate enums or declare variables or functions or similar. How do you generate values? First, we write a table of actions versus users. As cross macros can make it more difficult to understand a program, we precede the table with an explanatory comment so it will be clear how it works and how to add new actions or a new user. We can format our permissions in a neat tabular form. Each row of the comic actions table contains an action enumeration value, its index, and then for each user, the permission bit for that action expressed as a 0 or a 1. We have 4 users, so our table has 6 columns in total. In our example, the index is actually the C or C++ default enumeration representation of consecutive integers starting at 0. As it turns out, there can be gaps in the integer sequence, using GCC on an x86-64 architecture at least. In the example, we can see that Hancock and Steele can all do straight acting. The other 2 comedians don't have permission to do so. Next we have the generator macros. Every macro needs 6 formal arguments matching the 6 actual arguments that the table supplies. Here we have 2 generators to create the enumeration list and the maximum length values. These were covered in the previous video. And then we have a macro to generate each user's permissions bitmap. To create the permissions, each bitmap macro shifts leftwards its user permission value, a 0 or a 1, by the index value in column B for that action and adds a trailing bitwise inclusive OR operator. noting that this bitmap generator implementation has been developed on little endian architectures. Now all that remains to do is to use our generator macros to create the permissions bitmaps. An example is shown for the first user, Groucho Marx. So that it will compile, we need to end the table generator macros with a 0 because the cross macro table generator left us with a permissions expression with a trailing bitwise OR operator. To add a new action, you just need to insert a new row in the table at the desired location with permissions defined for every user. Then the index values for all the subsequent actions need to be incremented so that the integer sequence is maintained. Double check that there are no indices with the same value. Then rebuild and you're finished. Adding a new user requires a new column to be added to the table, with the permissions defined for every action. All the existing generator macros need an additional formal argument which they can ignore. And we then need to add a new action bitmap generator for the new user, shifting the new column's permission value by the action's index value, which is the same for all of the users actually. That concludes our second look at cross macros and how they can make your C and C++ code more maintainable. In this tutorial, a way to use them to generate data values. Please refer to Andrew Lucas's embedded.com articles to find some other applications of cross macros. I hope you found this useful and thanks for watching. There'll be more videos like this coming soon, so please like and subscribe. Goodbye.